Oh, that one it is?
Okay, number one. A building inspector makes a claim that the percentage of new construction with serious code violations is 7%. A second building inspector suspects that this claim, because he thinks the percentage is lower. A study is conducted which found 13 of 200 homes had serious code violations at alpha equal 0.05. The second building inspector should conclude that the first inspector's claim should be the null is P is equal to 0.07. That's the original claim. The second inspector believes that P is what? Less than 0.07, which makes this a one-tailed test. Since this is a proportion or categorical data, we're going to do a what kind of test? A one proportion z-test, which means we have to use the z-test, which is our sample minus the claimed P null divided by the standard deviation of our sample. P null is 0.07. P hat is what?
13 over 200.
13 out of 200, which is 0.065. 13 out of 200 is 6.5%. So 0.065, and then the standard deviation of P hat, that's the square root of P null, Q null over N. That'd be the square root of 0.07 times 0.93 over 200. And then for the sake of time, JJ, you said you have it. What is it?
0.01804.
Okay, so
Do you write bigger on the next one?
yes.
I did this again a different time. How much would it affect it if I used 0.70 and 0.30?
It'll have a big effect.
Okay, well that's what I did yesterday on the test. I didn't realize that I did put the zero. Okay.
Yep. So then the z-score formula would be 0.065 minus 0.7 over 0.018. Typing that in, 0.6065 minus 0.07. It's 0.07. And then divided by 0.018, you said negative 0.277?
Yep.
So negative 0.28, because it's a z-score, we round to 2 decimals. We're talking about a one-tailed test. Negative 0.28 is just to the left of center. And we're wanting to test the probability that it is less than, so we shade what? To the left. So to find the p-value, we can go straight to the z-score chart. Going to the z-score chart. Give me just a second, guys. Going to the z-score chart, going to negative 0.28. We don't need to change the sign because we're needing area to the left. Gives us 0.3897. P-value is 0.3897. Do we need to double it?
No.
No, it's a one-tailed test. And then we compare that to alpha. How does that compare to 0.05? It's greater than. So then that means that we're going to
Not be rejected.
fail to reject. So the answer is A, not be rejected. Fail to reject. If it's greater than alpha, or alpha is the probability of rejecting the null, given the null is actually true. If the probability of your sample is greater than that, then you want to fail to reject. There's not enough evidence to reject the null.
I didn't like the amount of A's I chose in that test.
Yeah, we
It
were
felt,
both-
it felt
Yeah.
it was unsettling.
Oh, sorry.
I felt like I was
Okay.
Yeah.
The following data is collected on 5 random vehicles. The miles per gallon were measured on the vehicle. What is the point estimate? The point estimate is what? It's X bar or P hat, but in this case it's X bar because we're dealing with quantitative data. we can go to edit our list. 23, 28, 19, 25, and 23. Typing that into list 1. And then calculating using one variable stats, we get the X bar is 23.6. If you were to run a confidence interval, would this be a T interval or a Z interval? It's a T interval. So this being a T interval gives us the margin of error formula is equal to T critical standard errors of X bar. Right? What kind of confidence interval are we trying to run? A 95% confidence interval. What's the degree of freedom?
4.
So we're looking for a degree of freedom 4 with a 95% confidence interval. And we get a 2.776. So the margin of error is 2.776. And then the formula for standard error, that's the sample standard deviation divided by the square root of the sample size. And once again, using the calculator, the sample standard deviation is 3.29 approximately over the square root of 5. And we get
1.47.
I get 469 around 1.47. And then once we have that, we just type it in 3.776 times 1.47. I get 4.08. I rounded. If I wouldn't have rounded, I would have gotten 4.09. So the answer is that.
So that would have been totally different if it wasn't a T.
If it wouldn't have been a T, we would have, instead of using 2.776 to accommodate for the small sample size, if it would have been a Z interval, we would have used 1.96 because of 95%, which will then drastically change our margin of error. I think it gives you 3.78.
Yeah.
So if you use the wrong interval, you'll get B instead of A. Number 3, scores on the Wechsler Intelligence Scale for Children, also known as WISC, are normally distributed with unknown mean, mu, and standard deviation, sigma equal 10. A researcher wishes to test the mean for his population from the national average of 100, so they test that the sample should be 100. He's testing it as not 100. He collects a random sample of 25, calculates a confidence interval, and he gets this as a confidence interval. Is what he expected to happen, mu equal 100, part of that confidence interval? Is 100 inside of here?
No, it's not. It's not inside.
100 is just on the outside of it, because this is 100.76. So that means we're going to reject.
It's all those A's.
It's going to reject because
I really overthought that one. I did
I'm
not.
really- I'm pretty sure it's
that goes back to that confidence interval chapter where if what we're testing is not an element of the interval, then it is abnormal. So we reject. I do. I'll continue to take a class. Guys, number 4, the researcher commits a type 1 error. That's just knowing this table. Null is true, null is false, reject the null, fail to reject the null. Alpha, beta, this is type 1, this is type 2. These are both bad things, right? And these are good things. So, if you commit a type 1 error, you have rejected the null given that the null was true. So D, rejected the true null. That's just knowing that table. That's just knowing that table. A 95% confidence interval for unknown population mean with a population standard deviation. Guys, this right here, population standard deviation, tells you that that interval is created around a what kind of Z interval. So this is going to be a Z interval. That tells you it's a Z interval because it tells you the population standard deviation. And in any case, in any kind of interval though, The sample mean is always where? In the middle. So to find X bar, you take the extremes, add them up, divide by 2.
So 73 minus 2.
I seriously was saying
It's
that.
the only one that.
Well, and then also, it's use test taking strategies. The sample mean has to be somewhere in here. The only option that is in there is C. Right?
That's an ACT thing right there.
You try to overthink it.
I think it might be 73.
And then the sample size, that takes advantage of the margin of error formula. The margin of error formula is Z critical, standard error, and the standard error in this case is sigma over radical n. So let's fill it in. We can find the margin of error. The margin of error is how much it fluctuates on each side of the sample mean. So if you want to find out how much this interval fluctuates on each side of the sample mean, you take either of 4 of these outside values of the interval, so 41.03, and you subtract what?
The mean.
The mean. So you get a margin of error of
4.5.
4.53. I think the mistake on this test was everyone's just wanting to subtract the endpoints of the interval. But the interval makes up how many margin of errors? 2, one above and one below. So if you subtract these two numbers, that can be done. But then you've got to take that answer and do what? Divide it by 2. They give you the same answer, 4.53. So this is 4.53. The Z critical for a 95% confidence interval. 1.96. Sigma is given to us. And the only thing that's left to solve for is the sample size.
Is it better if you read the end first?
It's however you want to do it.
Or you read the end first?
Yeah, move the radical n over. 4.53 radical n.
You just switch.
Yes. Is equal to 1.96 times 20. Divide the 4.53 over.
Square.
Wait, but you know the sample.
Now,
You read
yeah,
it. It says, oh, never mind. No, sorry, that's it.
and then to get rid of the square root, we would
Square.
square. And then you just type it in. 1.96 times 20 divided by 4.353. 4.53. And then squared gives you n is equal to 74.88. The answer is B, 75.
That's the one where it's squared before something.
Yeah, if you square before you divide it, we'll change that. Yeah. Yeah, I think you squared 1.96 times 20, then divide by 4.53.
I didn't mean how to put it all together. Like I forgot that it was,
All being squared.
and because that's how I got 64 with that.
I'd say, yeah, I'm not sure how you got 60. There's several ways that you could have typed this in. So, main thing is, if you're worried about that, is just go ahead and figure out what 1.96 times 20 is right off the bat. Then divide by 4.53, write that decimal down, and then square it. So you're instead of having to deal with several decimals at the same time, just deal with one decimal at a time. The only issue with that is, if you start rounding at the very first step, as you're rounding, it's going to throw off the answer a little bit. But it's not. It shouldn't throw it off significant enough to make that kind of a jump in difference, 11 or 25. So,
How do you find the margin of error again?
the margin of error,
Secret.
the critical standard error is
No. How do you
Oh, okay. How do you find it from the interval?
Yeah.
Remember, your interval, directly in the middle of your interval is X bar. And then you've got plus margin of error on this side, and you've got minus margin of, I'm trying to write it back, margin of error on this side, giving us your two lower and upper limits
Okay, so you just
of the interval.
one of the extremities minus the X bar.
Exactly. Or you can minus the two extremities and then divide by 2. You'd be having 2 marks, either or. Number 6, ACT scores are normally distributed with a mean of 24 and a standard deviation of 4.8. And normally distributed, meaning of standard deviation tells you we're going to use the Z-score formula. Okay? The minimum ACT score, so it's asking for a raw data point. It's asking for a raw score that is needed to place a student. So we're talking about a sample size of 1 in the top 5%. So we really just need the formula x bar minus. I mean, we can apply this formula.
Did we do this before?
We did this. Yeah, we
I
did
mean,
this.
Did we use the formula before? Because I thought that we didn't know the formula.
Yeah, we did. Yeah, but I mean, we can use this formula. But what's the sample size going to be? 1. So you're going to have sigma over square root of 1, which is just sigma, right? So, anyways, we need to. So we're needing a raw score, and it's giving us that the student wants to be in the top 5%. So, so we've got this raw score can be switched interchangeably with z-scores, which can be switched interchangeably with p-values. Okay? It's asking for a raw score, and it's indirectly giving us a p-value. And why I say indirectly is p-values are always areas to the left. So being in the top 5% means that the p-value is 0.95. That's the p-value for this problem. And if we want to take a p-value and convert it to a raw score, we've got to use the transition value of converting it through using the z-score formula. Okay, so if we know p is equal to 0.95, what's the z-score that results in that?
1.69.
If we go to 0.95, it is 1 point, well, there's 2 of them, right? But only one of them's in the top 5%, and that's at 1.65.
Would it be a big difference if you did, you feel?
It's not going to be, with it being a multiple choice test, it's going to make a difference of a hundredth of a decimal, so no. So z is 1.65, and then to convert it to a raw, we're going to use this formula. We know z is 1.65. We want that student to get a mean of 24, or sorry, we're trying to find that student, right? Minus what should happen, which is 20.4 over 4.8. It's a two-step equation. Times by 4.8 gives us 7.92 is equal to the data point minus 24. Adding 20.4 gives us x bar would equal 28.32. So the answer is D. So it gives us a p-value indirectly. We've got to convert that back to a raw score. The way we do that is we use the conversion of the z-score formula. Times by 4.8.
Is that 7.12 or 0.2?
92.
So how do we know for sure that it's just one? Put a number there.
Keyword, place
What's the keyword?
a student.
A student.
One student.
Insert.
A random sample of n equals 35 adults is selected and given an IQ test where the mean is 100, standard deviation 15. If their sample mean was 92, what's their z-score? So that's just asking you to use this formula. You just fill it in. What was the sample mean? 92 minus the mean of all IQ tests is 100 over, and we're not talking about the standard deviation of one person, we're talking about the standard deviation of a group of people. So it's not just 15, it's 15 over the square root of 35. Because when you're talking about taking the average of the student, you got to divide by, or average of several items, you got to divide by the square root of the sample size. So 92 minus 100, that's negative 8. And then divided by 15 over the square root of 35 gives us negative 3.155. Is it now? One of the biggest mistakes was knowing where to stop. What's this asking for? Z-score. It's not asking us for a p-value. It's asking us for a z-score. We're done. We've got the z-score. Negative 3.16. Which measure of center would be appropriate for describing household incomes for a family in a very large city? It does not matter where you do incomes at. Anytime you do income, what kind of distribution is the data going to be? It's going to be skewed data. You're going to have a bulk of the people making little money, a few people making a lot of money, throwing off the measure of center, forcing us to have to use the what? Median. Okay, that's second day of class. We went over that. Yeah, median is always better, but when it's normal, the median and the mean are the same.
Yeah, so median is always.
The regression equation. 860 or fat can be predicted by 816.14 plus 11.33 times sodium content. If the residual of the burger of ID of 7 is negative 43.31, how do you interpret this residual? The residual formula: error is equal to observed minus predicted. Observed minus predicted, or actual minus predicted. I would just remember this formula, EOD, because these are listed in alphabetical order, right? Because if you do predicted minus observed, if you get those two switched up, it's going to throw off things. So to do EOD, it's in alphabetical order. Error is equal to observed minus predicted. That being negative tells us which one had to be the smaller of the two. In order for the residual, the error to be negative, someone said it. JJ? In order to be a negative, the observed would have to be smaller. Where you're doing smaller minus a bigger. So the observed fact, right, is 43.31, in this case, lower than the predicted what? Fat, right? The observed fat is 43.31 lower than the predicted fat.
Why would we use fat instead of sodium?
Because when you plug in something, you're making a prediction about fat using sodium. So sodium is what the sodium is the one doing the predicting, but you're predicting about fat. The predicted grams of fat for a burger with 25 milligrams of sodium is, it's telling you 25 milligrams of sodium. You're just going to plug it into the equation. 816.14. Predicted fat, 1.33 times 25.
What is on this side of it?
Predicted fat. That's half, right? Sarah, do you have it? What is it? B. The best interpretation with this slope, looking at the slope up here, 11.33, is it positive or negative? Positive. So is this going to be an increase or a decrease? Increase. Increase. And it's going to be as sodium increases 1, the predicted fat increases 11.33. So there's that. That's just interpreting the slope. As sodium increases 1, predicted fat increases 11.33.
How did you know it was did you say because it was a positive number?
Yes. The positive implies that it's going uphill, right? If you were to graph it, it would be a linear function that's increasing. Guys, I want to skip number 10. Here's why. We did number, what was it? We did number 6 and 7, right? We'll come back to number 10 if we have time. But if you notice, instead of being the minimum score required to be in the top 5%, it's the top 10%. And then the second one deals with a random sample of n equal, and it's not asking for a z-score, it's asking for a p-value because of the term probability. I have to work them out real quick. We'll come back to them. My intention is to get back to them, but we've already done one similar to it.
If we don't get this, are you going to report it in 30
Yes, I can do that. I'll record the rest of the review. Number 11, the independent variable is
Wait.
Remember, independent is x, dependent is y.
Dude, where's my letter?
Yeah. It's called instead of copying and pasting, because I have to copy and paste all these pictures, I just cut and taped. It was a lot quicker than copying and pasting all the pictures to a single Word document. The relationship between weight and miles per gallon. It's definitely negative, and all those points are relatively close to that line, therefore we say it's strong and negative.
Do we have to like
These questions are what at least gonna
Yes.
Do what?
I was about to say the same thing.
do we have to find the line on our calculator? Assess the. Cause I don't.
The best approximation of miles per car for a gallon, or for a car that weighs 2,400 pounds. You get a 2,400 pounds. The approximation, is it the point that occurred or is it the line?
Approximation line.
It's the line, correct. So we go up to here, we go over. It's somewhere slightly above 38. 39. Number 12 is a weighted average. A small warehouse employee is a supervisor, $1,200 per week. So how many people make $1,200? One. An investor manager makes $830. One person. Stock boys make $450. And there's how many of them?
6.
6. And then drivers, 4 of them make $550. You add all that up and divide by what? 12. That's right. You have to divide by how many people there are. Even though there's just 4 numbers being added up, some of them numbers are repeated, therefore it's a weighted average. We have to divide by 12 because there's 6 stock boys, 4 drivers, 1 manager, and 1 supervisor. Giving us 12 total people. Anybody have that?
Sounds like pretty much like bean stuff that we did in like 6th grade.
Yeah. Someone have it? C.
That's so not what I got.
Okay, Sarah, I would work out the top first. 12 plus.
Oh, I forgot a number. Okay.
We good then?
Yeah.
The z-score that represents the 90th percentile is blank. You have to know how percentiles work. Percentile is the percent of people that you did better than. So being in the 90th percentile means that 90% of the people are below you, right? If it said Q1, how much is below Q1? 25. The median, how much is below the median? 50, and how much is below Q75? So, p-value is 0.9. Keyword, percentiles are for the p. We find 0.9. Let's see here. We've got 2 of them, 1.28, 1.29. 1.28. Obviously, 1.28 is closer than 1.29 on the SAT. Let's see here. We did one very similar to 14A, right?
Yeah.
We did one very similar to 14A. I will go over 14B though. This is a raw score, right? This is a raw score. What's it asking for? It's asking for a
Area to the left.
percentage below. So it's asking, and yeah, to the left. So it's a p-value. So the way we take a raw score and we convert it to a p-value is we have to find that raw score's standardized z-score. So we use the z-score formula. It's what we're interested in minus what should happen. Data minus mean over the standard deviation of data. Divided by the standard deviation of our data, which is 209. We're only interested in one score. So we get a z-score of negative 0. What? 36. Okay, so let me
Oh, are
just
you using the?
we're just using the z-score formula.
I was wondering if you were using the question before.
Is that one?
We're using, yes, yeah. This instruction's applied for A and B. What is it?
Standard deviation. Is this one x bar minus x over standard deviation?
Yes. X minus X bar.
There you go.
Data minus what should happen. Yes.
I said that one. Over the
Technically, it's the same as this formula. But what's our sample size in this case? We're only interested in 1, so then it turns into, you see what I mean? It's all related. So, But yeah, it's x minus x bar over standard deviation of that. So we get negative 0.36. If you're not paying attention to what you're doing, you might think the answer is A, right? But this is a z-score. That means, now one thing that's important, this is negative 0.36. We want the percentage that is what? Below. Do we need to change the sign of it when we find its p-value? If it's to the left, do we need to change? No, that's only if it's to the right. Yeah, that's important to remember. So we get a negative 0.36. And, well, that one happens also. That happens. That's not it. That does not happen. We get 0.3594. Yeah, that is a coincidence. Okay. Do not bank on that being the case all the time. A z-score of 2 does not mean 200%. Okay? That is a coincidence on this problem. So if you made that mistake on this one, you are still okay. Researcher asked a group of students to provide their political party. Which of the following would be appropriate? We're talking about what kind of data? Categorical, so therefore we use a pie chart.
So do we know like each one is which one of these are not?
Yeah, when they do that. Yeah. A box plot is a box plot. What's the box plot beneficial for?
No, the summary, the 5-number summary.
Well, the 5-number summary, but also the outliers, because the 5-number summary doesn't tell you if there's outliers, but if you see a graph of a box plot, you can identify it
Okay, in
visually.
my head it's 5-number summary.
And then the histogram tells you distribution shape.
Yeah, but what about the scaffold? What's that?
Scatter plots for a linear regression correlation.
Just
What?
Correlation.
Wait, will there be a question on the 5-number summary?
You what?
The 5-number summary, will there be a question?
We're gonna get to that. It's number 17.
Okay.
What's the history?
What histogram is distribution shape, whether it's normal or skewed? Number 16. What percentage of the scores is below a z-score of 1.15? So it's giving you a z-score and it's asking for a p-value.
below 87.
1.15 is here, it wants percent below. That's area to the left. Do we need to change the sign of the z-score?
No.
No. So and this one is definitely not 115%. So you do have to know to use the chart. 1.15 is 87.49%. You do have to know to use the chart. It is not just work out the word the z and the p with double z.
Yes.
In general, the 5-number summary, guys, that's just something you should know. A. The smallest, the largest, the middle, and the middle of the two halves. Then minimum Q1, median Q3, maximum. Reading a histogram. The median. When arranged in order, the median. When arranged in order, the median occurs where? Directly in the middle. So the first thing we need to do is figure out how many's in this data set. If you add up, there's 15 in this, 40, 10, 25, and 10, we get that there's a total of 100. Okay, so the median is going to be centralized around the 50th entry. It's going to be the average of the 50th and the 51st because this is an even number. Where does the 50 and the 51st entry come from? This is 15, this is 40, that's the first 55, so the 50 and 51st happens right here, which is in the 75 to 80 range.
See that I get the 100 divided by 2, right?
You divide by 2,
That's all you.
and then if it's even, you also add 1 to it.
Oh yeah.
Yeah, so since this is even, it would be the average of 50 and 51, and those both fall in the 75 to 80 category. If it was odd, let's say if it was an 101. If it was odd, you add 1 to it, then divide by 2, which makes, let's see, if I can do the math correctly, 51. Right. So if it's if there's an odd number, then it's just the 51st, the add 1 divide by 2 entry. But if it's an even, divide by 2, add 1, and it's the average of those two. Because there wouldn't be one specific, JJ, if it's even. There's not going to be one specific number in the middle. There's going to be 50 above, 50 below. There's going to be 2 numbers that straddle what's directly in the middle. JJ, you already said?
Yeah.
Okay. Making sure. Box plot.
How do you read this again from top to bottom?
You always do. The smallest is the
Alright.
min. The first bar is Q1. The middle bar is the median. Q3, and then the max.
So did the first one just not have a max?
It's up here. The max is an outlier. The max is an outlier.
Oh, I see it.
So, reading through this, anyone have it?
B.
B, the first quartile of northeast was higher than the third quartile of northwest. That is true. So it is B. The Chronicle on Higher Education reports that 28% of Americans age 25 has at least a 4-year college degree. You randomly select 350 Americans age 25 or higher. The probability that 102 or more of them have a 4-year degree is blank. Okay? So, we have P hat. Is 102 out of 350. If we conduct a study and we repeat that study, theoretically, what should be in the middle?
0.29. Below the mean.
Chronicle on Higher Education reports that 28% of Americans. So if we conduct it, if we have a national value to compare to, 0.28 should be in the middle. Right? We got 0.29, which is a little bit more than that. It wants to 0.29 somewhere right here. And it wants to know the probability that 102 or the probability of 0.29 or more than. So we're interested in area to the right. That means we're wanting a p-value. In order to find a p-value, we've got to have a z-score.
In that case, you use a negative, right?
So we do, yes, you would. Correct. So the z-score formula is going to be what we got minus what we should get divided by the standard deviation of our data. Standard deviation of p hat. What we got. And the standard deviation of p hat is the square root of PQ over N. Remember, okay, Jay said that you said 0.29. It's not 0.29. P is 0.2. We use 0.28.
Oh.
Because if we have a population, if we have a population proportion, that's what we use to calculate our standard deviation. If you're using your sample, then you're calculating standard error. You do that 0.29 for the standard. You see what I'm saying? We use P because we know the population is 0.28. Then the Q would be 0.72.
So it's always where you use the population.
You always use the population if it's not, then you're dependent upon using your sample. But since the sample is given to you, we use, or the population is given to you, we use it.
And Q is Q 1 minus.
P. Q is, yes, good. Q is 1 minus P. If there's a 28% chance of success, there would be a 72% chance of failure. The standard deviation of P hat is 0.024. So then we plug it in. P hat minus P over the standard deviation of P hat.
0.416.
And we get, okay, so 0.42, right? Round to the second decimal. Now, so that means that this line here has a z-score of 0.42. We want to know the probability that it's more than that. So we need the area to the right. So when we're calculating the p-value, we will have to use the negative z-score. So we'll go to find this p-value, we will go to negative 0.42. Value equals, and going to negative 0.42 gives us 0.3372. Maybe I looked at that wrong. What have I done wrong? There's a mistake somewhere. Hold on.
I don't know. We'll go mess this one up.
I want to see it like it's.
I don't think we did. No, I don't think we did anything wrong. I think the fact that we stopped the p hat at 0.29 caused our answer to be off a little bit. So it is C. Yeah. There's no. The fact that we rounded the p hat and we rounded the standard deviation caused our answer to be slightly off.
So is it safe to always use 4 decimals?
I would just use 4 decimals. Yeah. The more the merrier. The more you've got to type in, but to get the most accurate result, yeah. Technically, if you just use the answer button.
So
Could
it always
use it.
screws me up sometimes. Like, is there like a formula for P hat? Like a formula?
Yeah, p hat is always the number in the sample, that committed to success, over total sample. So if you, so you're interested in 102 people committing success or more out of a total in the sample of 350.
The z-score is 0.42 here, but if you do that what you said, it's 0.48.
Gotcha. That's okay. So now I went ahead and calculated it. If we would not have rounded these two, instead of getting a z-score of 0.42, we get a z-score of 0.48. So those two roundings threw the answer off that much, which will then fix the dilemma of the p-value. Thank you, Tyler. 21. IQ scored are normally distributed with a population standard deviation of 15. That's important there. We wish to estimate the average IQ. We select a random sample of 32 students and get a sample IQ of 115.25. What type of interval are we going to create? We know the population, so it's a Z. Guys, I will finish recording this video momentarily. I will post it on YouTube, and then it resumes. So with this problem, since we know the population standard deviation is 15, we're doing a Z interval, which means that we're going to do X bar plus and minus Z critical standard error of X bar. X bar, the sample mean is 115.25. That's given to us. The Z critical is 1.96 because we're dealing with a 95% confidence interval. The standard error of X bar is population divided by the square root of M. Population is 15. That's given to us. Over the square root of 32, because we have 32 students in this sample. So we do 15 divided by the square root of 32, giving us a standard deviation of standard error of 2.65. So our confidence interval is 115.25 plus and minus 1.96, 2.65. And then subtracting 1.96 times 2.65 from 115 gives us 110.06. And then adding that, which is the only option in the answer, that has 110.06, so we know we don't need to go any further, but it would be A. Would you expect the width of the confidence interval to increase, decrease, or stay the same if you do a 90% confidence interval? If you are doing 90%, when you decrease the confidence from 95 to 90, when confidence go down, margin of error goes down. And as the margin of error goes down, the confidence interval is going to decrease in size. You're going to give a more specific answer, but you're going to lose confidence in the accuracy of that answer. And then, based on the results of our confidence interval, assume we're told the average IQ of a high school football is 112.05. Based on the results of your confidence interval, which is 110.06 to 120.44, does this result, 112.05, seem to be reasonable? Is it an element of this? Yes, it is. Therefore, yes, it is a reasonable response. 112.05 is an element of our interval. Therefore, it is a reasonable. We're asking about reasonable result. Linear regression. Predicted highways, 4.62 plus 1.109 city mileage. A vehicle that was included in the study had a city mileage of 22 with a highway mileage of 28. This is the observed. To find the residual, we're going to do error is equal to observed minus predicted. error is equal to the y value that occurred minus the predicted y value. Highway mile per gallon. The y value that occurred is 28 minus the predicted is 4.62 plus 1.109, and we take the city that we're interested in and plug it in. The 4.62 plus 1.09 times 22 gives us 28.6. One second, it does not give you that. It gives us 29.018. Subtracting those gives us negative 1.018. The drug company makes a claim that they produced approximate sodium is 220 milligrams. The pharmacist suspects the claim and wishes to test it. Notice the pharmacist does not want to test higher or lower, simply test the claim. So the claim is mu is 220. The pharmacist is wanting to test that mu is not 220. So it's a two-tailed test. She randomly selects n equal 5. Here they are. It's raw data, so this is going to be a t-test. So we're going to do t equals our sample mean minus the null mu divided by the sample standard deviation over square root of n. In order to get this information, we have to punch this in as a list. So we're going to edit our first list. Punching these in, 209.1, 214.2, 202.4, 212.6. Doing a one variable stats analysis on that gives us a sample mean of 209.5, a sample standard deviation of 5.37. Plugging that in, 209.5 minus 220 over 5.37 over the square root of 5. I had made a mistake somewhere. Give me 1 second. First off, this is a t-test. Let me check if I get it on the list. 209.1. Oh, I have left out one of my terms. I have left out the 204.9. So typing 204.9 in gives us, this is 208.85, and this is 5.09. Another typo, guys. 202.4 I typed in as 202.1. So 209.1, 204.9, 214.2, 202.4, and 212.6. Stat, calculate one variable stats on list 1, gives us 208.64, 4.99, 208.64 minus the claim, divided by 4.99 over the square root of 5. 208.64 minus 220 gives us t is negative 11.36, divided by 4.99 over the square root of 5 is 2.23. Negative 11.36 divided by 2.23 is a t-score of negative 5.09. So the last 2 minutes said, guys, it's very important that you make sure you type in your data correctly when you put it in your list. If not, it screws up your final answer. So we do get by negative 5.09. The appropriate decision, since this is a t-test, what we need to know is we need to know what t-critical is. The way we find t-critical is we need to figure out the confidence interval that we're interested in. If it does not give us an alpha level, which it does not, we assume alpha is 0.05. We're doing a two-tailed test, which means that each of these regions has to make up 2.5% of the curve. making this a 95% confidence interval. So we go to our 95% confidence interval column on our T-chart. We go to degree of freedom of 4 because there's 5 elements in this data set, making our degree of freedom 4, and we get the T critical as 2.776. And then we ask ourselves, based on that T critical, where does our test statistic happen? And if this is negative 2.776 to 2.776, negative 5.09 is over here, and the shaded regions are your rejection regions. So we're going to reject the null hypothesis. That finishes up the review for the final exam, guys. There is one problem I did not go over, and that's number 10. But I said in class, 10 is very similar to another problem in this. If you have questions about 10 specifically, email me with those questions. Good luck.